So we will talk about Lienard equation to prove the Lienard theorem, which says that the Lienard equation with a certain condition only have unique periodic orbit. We will use the following notation, and this is of course containing the case of van der Pol equation. By the Lienard transform, the first two terms can be written as y dot, introducing another variable y. Then you can make it into a planar dynamical system using x and y variable. To prove the Lienard theorem, you will make the following assumption about the function f. So first, f is an odd function, so f prime will be an even function. Since it's an odd function, we only have to define f on the positive side. And the positive side, we have the following property. And we will further assume that f is monotonic after x is larger than alpha. So if you draw the graph of f of x, then it's the graph that we saw in the null line for the van der Pol equation. Symmetric with respect to the y-axis and upside. So it's an odd function, and it intersects at the x-axis at alpha and minus alpha. Note that this line is still a null line where x dot is equal to 0. And like in the van der Pol's case, above this null line, the x dot, the horizontal component, is positive, and below this null line, the horizontal component is negative. We will define the right half plane to be h plus. H plus is all the coordinate where x is positive, and h minus is of course the other side. And we will define y plus to be the positive y-axis. So it's 0, y for all the y positive. And y minus will be the negative side of the y-axis. So it will be also 0, y for y negative. And let me first prove that any point on h plus, the right half plane, can intersect this graph, the null line, at most once. Whether it crosses the graph of f or not, you can check by calculating the equation of the graph. Equation of the graph is here, y minus f of x equal to 0. So we will see whether y minus f of x becomes 0, or we will check how this function varies over time. So if you calculate the time derivative, you get y dot minus f prime of x times x dot. And that expression can be changed using the equations of motion. So y dot is equal to minus x, so minus x. And x dot is equal to y minus f of x. So I can write y minus f of x. And this means when it intersect, when it cross, this happens, y minus f of x is equal to 0. And when that happens, the derivative of that expression is always minus x. And minus x is negative at h plus. And therefore, it means all through this curve in h plus, the motion is always from the upside to the bottom side, where y minus f of x is positive to negative. Never go back to the other direction. So the motion is always crossing the graph of f from the upside to the bottom side, which means it can only cross only once for any trajectory in h plus. Next lemma is we consider the following function, which is 0 at the origin and growing positive at the other point. And we take the time derivative of this function. And again, using the equations of motion, then we obtain this, minus x times f of x, which is, according to the this condition number 2, which is positive, because of this minus sign, minus x times f of x is positive near the origin, actually from minus alpha to alpha. So these are positive when x is minus alpha to alpha, and a negative when outside, otherwise. And by the Lyapunov theorem, that in fact actually shows that the origin is unstable fixed point.